Let's break down the DeepSeek mixture of experts architecture. To understand how it works on a single machine, we start at the very beginning, the input X. That is a 3D tensor of the shape batch times sequence length times the D model. Before we can route anything, we apply a view transformation to flatten this tensor into the tensor of the shape number of tokens times D model, where number of tokens is a multiplication of batch times sequence length. From here, the architecture splits the data down to completely separate paths. One is shared expert, another is a gated expert. The first path functions exactly like a classical MLP layer. Every single token in the batch is processed through this identical expert. Second path begins with a gate. The gate's job is to look at every single token and decide which of the specialized experts are best equipped to handle it. You as a user define top k, which is the number of experts, and it outputs two crucial tensors that are weights and indices. Weights correspond to confidence scores for each routing decision, and indices contain exact IDs of the chosen experts. Before we actually do any calculation, we first do optimization trick here, and we count tokens assigned to each expert. We need this because if an expert has 0 tokens assigned to it, then we just skip it and go to process next expert. So the routed expert performs its computation, but only on the specific tokens assigned to it. It outputs a tensor of the shape number of expert tokens times D model. And because we have multiple experts running in parallel, and the output corresponds only to tokens it's been assigned to, we have a trick here where we first create a container called yExpert that has the same shape as an input, number of tokens times the D model, and then it stitches all the outputs of routed experts to these yExperts using the indices also calculated in this expert calculation block. And finally, we take output of our path, shared and specialized experts, and sum them up together, and we obtain a final Y tensor. Modern architectures, including DeepSeek, don't use standard MLPs inside their experts anymore. Instead, they use advanced architecture called SweGLU. If you want more details, you can read famous 2020 paper titled GLU Variants Improved Transformer by Noam Shazir. First, we have an input that it's not all the tokens from the batch, but only tokens that has been assigned to this expert by the gate. Instead of passing through a single linear layer, this architecture immediately splits this input tensor and runs it through 2 linear layers in parallel. Both of these layers project the data from our standard D model dimension up into a much wider space, which we call H. The first linear layer is called the gate projection, and the second one is called up projection. For the gate projection, we also apply CELU activation function. Then we combine these 2 outputs using element-wise multiplication, followed by a linear projection back to the D model space. The gate architecture is quite simple, and again we start with an input tensor called X tokens, and then we project it to a new geometric space of the dimension number of experts, and then we call the softmax function that creates the probability distribution across all these experts for each of the token. And then because we only want to route tokens to top k, we run top k PyTorch function, and the outputs of which are weights and indices corresponding to the maximum experts with maximum values. So going back to the entire mixture of experts architecture, there was this block called expert calculation. So let's look in more details how it's done. And the input to it are, again, X tokens, but also indices and weights created by the gates. And because we want to run it for each expert specifically, we first need to extract rows and columns for these indices tensor for expert I. And then these rows and columns are used first to only take the tokens from the input stream that were assigned to specific expert I, and also filter the weights here, and for each token extract what is the weight for the current expert I, and then we multiply the Y expert by its weight and write it back to the output container.